Kia ora. Using the properties of logarithms when differentiating. Last year, we looked at these notes and I thought I'd recap them before we actually look at differentiating some logs in more depth. So rearranging a logarithmic statement. Log n to the base b equals x is its log form, and that can be converted into index form of b to the power of x equals n. Within this, x is representing the log, n is the number, and b is the base. So in addition to this, because logs are powers or indices, they follow the index rules. So when multiplying numbers, we add the logs. So we've got log of a times b is equal to log of a plus log of b. Also, when dividing numbers, we subtract the logs. So log of a divided by b is equal to log a minus log b. Looking at that first rule I just did there was log a times b equals log a plus log b. Following that, if we had log of a to the power of 4, that means it would be the same as log a times a times a times a. So we could then break that down and say that's the same as log a plus log a plus log a plus log a. How many of them do we have there? We've got 4, so it's 4 log a. That generates this final rule, which is log a to the power of b is the same as b log a. In other words, that power can be brought out the front, and that is one of the most powerful rules we often use with logs. In our last lesson, what we did is we looked at this example here, and I showed you how you could differentiate ln of x to the power of 7. And effectively, it was just writing it down on the bottom line and timesing by the derivative on the top line, and then simplifying. If we focus on the log rules, another way we could have looked at this question is to have actually converted that by saying that power, 7, we could bring out the front. So that means this question is the same as what's the derivative of 7 log x. And because it's just being multiplied by 7 as a constant out the front, you can actually pull that out, and then really what you're doing is just differentiating log of x, which is 1 over x. And that would also give us the same answer of 7 over x. So just another way of looking at that question. The second example I looked at yesterday was what's the derivative of log of 5x to the power of 7. So again, writing on the bottom line 5x to the power of 7, differentiating that and putting it on the top line, then simplifying gave us 7 over x. So another way we could have looked at this question was to actually break down that function 5x to the power of 7 and say, well, that's the same, because it's like log a times b, it's the same as log a plus log b. So it's log 5 plus log x to the power of 7. And then you could also then pull out that 7 out the front. So if you differentiate log 5, that's just a constant, so that's going to differentiate to 0. When we've got x to the power of 7, so log of x to the power of 7, we've already sort of figured that one out, that's going to just give us 7 over x. So again, we're getting the same answer, we're just using some of our log rules sometimes. So there's a couple of exercises that relate to this. First one is on page 271, exercise 15.05, and then there's also a follow-up one there on 15.06. So what I'm suggesting is maybe every second question on the first exercise there, and then there's only a couple of word questions for the second one. You could maybe try those both. All right, good luck.